In the second part of section 5-1, we're going to talk about vertex form, axis of symmetry, and how to identify the minimum and the maximum of a function, as well as the domain and the range. So, when a quadratic function is written in vertex form, you can easily identify the vertex. And I have a little diagram here that tells you what each thing that does. This indicates if it's a reflection. So if you have a negative here, it's going to reflect. And this indicates the horizontal transformation. This indicates the vertical transformation. All right, so if you are in vertex form, we can find the vertex of the function very easily, because just remember the parent function goes through, the vertex goes through 0, 0. If we move this 4 units, and we have to think this is the horizontal house, so we think opposite. If it says plus 4, we're going to move it to the left 4. And vertical, what you see is what you get. So if it says minus 5, we're going to go down 5. So our vertex here is going to be negative 4, negative 5. Very easy to find if you're in vertex form. Now, also if you're in vertex form, you can find easily the axis of symmetry, because the axis of symmetry is the line that goes right through the vertex of the parabola. It's like the fold line. So since this is a vertical line, we would say x equals h. So your vertex also gives you your axis of symmetry. So we're just going to write down axis of symmetry. Oops, that should be 2 m's. X equals negative 4. That's the equation for this line, for this vertex. So the axis of symmetry is also called the x-coordinate of the vertex, and that means the axis of symmetry in example 1, and we'll just write it down again here, is x equals negative 4. For parabolas that open up or down, the axis of symmetry is a vertical line. Now next year you'll deal with parabolas that open left and right, but this year you're just doing up and down, which means you have a vertical axis of symmetry. So you must always write x equals, x equals when you're writing the axis of symmetry. Okay, let's talk about the minimum and the maximum values of the function. If your parabola opens up, and when we're talking about the minimum and maximum values, we want to look at the vertex. So here is our vertex. If our parabola opens up, we're going to have a minimum. If our parabola opens down, the vertex is going to be the maximum. It's at the highest point on the parabola. Okay, now this parabola is going to keep going forever this way and forever this way. So if we look along the x-axis, it's going to include all the values to the left, all the values to the right. So for that reason, we say that the domain is all real numbers, and that's for parabolas that open up and down. Now next year when you get left and right, that's going to be a different story. But for now, our domain, whether the parabola opens up or down, the domain is going to be all real numbers. So that's how we talk about the domain. Now to talk about the range, we look at the vertex. And we look at the lowest value or the highest value, depending on if it's a min or a max. So let's just fill in a few blanks here, and then we'll look at an actual example with vertex. The minimum or the maximum values are found at the vertex. They are represented by the y-coordinate of the vertex, not the ordered pair. Oops. Okay, so the vertex we have here is at 2, 2. We know that it's the lowest point on the parabola, so it's going to be a min. And now we have to say where the minimum is at. Well, we look at the y-coordinate, so it's going to be y equals 2. Our domain is going to be all real numbers for both of these, so let's just go ahead and fill that in also. And the range, we have to look what are the values of y? The smallest value we have for y is 2. So we say y is greater than or equal to 2. And then over here we have a vertex of negative 1.56. And since the vertex is the highest point on the parabola, we say that it is a max. Okay, now we have to say the y-coordinate for the max. So this is going to be y equals 6. Our range, the highest value y can be is 6. So now we say y is less than or equal to 6. Let's add in the axis of symmetry here. So the axis of symmetry, let's just write it off to the side here. Axis of symmetry for both of these is the x-coordinate. So we say x equals 2 because of the x-coordinate. And here we say x equals negative 1.5. So the y tells us about the min or the max. The x tells us about the axis of symmetry. All right, now we're going to put yesterday and today together, and we're going to graph and identify a few things here. So we are going to graph, and the first thing that we need is the vertex. When you're graphing a line, the first thing you want is the slope, or the y-intercept, and then the slope, and you can graph your line. With a parabola, you need to start with the vertex. So if you're in vertex form, again, we take the opposite of this, and we're going to put the vertex form right in the middle. And I'll tell you why in just a minute. So this is going to be negative 1, negative 3. Now, because this is positive right here, the parabola opens up. Our axis of symmetry is always, think of axis, that has the x in it. So we're going to say x equals negative 1. Our vertex we identified as negative 1, negative 3. Okay, now we need to find 2 points to the left of the vertex and 2 points to the right of the vertex. So that's why I put the vertex in the middle here, because we want 2 points over here and 2 points over here. So if this is negative 1, I can go negative 2, negative 3. And if this is negative 1, I can go 0 and 1. Okay, so we can go ahead and graph our vertex. So go ahead and do that. And now we're going to, so at negative 1, negative 3, and now we're going to substitute 2 into here. So 2 minus 1 is negative 1. Or sorry, 2 plus 1 is going to be 3, squared is 9, minus 3 is 6. And that, I'm sorry, this is actually a negative 2. I said 2, but it's a negative 2. Okay, so let's fix this. This is negative 2 plus 1. That's going to give me a negative 1. I square it to get 1, and I subtract 3, so that's going to give me a negative 2. Now I'm going to go on the other side here of the vertex, and I'm going to put 0 in here. 0 plus 1 squared is 1, minus 3 is negative 2. All right, now let's go back up to this negative 3. We'll put negative 3 plus 1, that's negative 2. We square that, we get 4. So let me just write this in here. Negative 3 plus 1, that's going to give me a negative 2 squared is 4, minus 3 is 1. Now I'm going to go back down over here to the other side of the table, or the bottom side of the table, and I'm going to put a 1 in here. 1 plus 1 is 2. I square it, I get 4. I subtract 3, I get 1. Now the reason why I went back and forth like that is because I want you to see that on either side of the vertex, if you choose points that are 1 unit away each time, you're going to have symmetry here. So we have negative 2, negative 2. I'm going to graph that. Negative 3, 1. And then I have 0, negative 2. And I have 1, 1. Okay, now I can connect those points. And I have my parabola. And the last step says, identify the transformations. Well, if we go back up here, and I need to erase some of this because I wrote all over it. This is the horizontal house. So we have a horizontal, because this is adding, we have a translation. We take the opposite. It says plus 1, so we have to think minus 1. So this is going to be a horizontal translation to the left, 1. And then this 3 is not in the horizontal house, so that makes it vertical. And it's going to be a vertical translation down 3.